Good afternoon, everyone. I welcome you into this class. My name is Dr. Aderoji. Today, I want to discuss a topic on introduction to probability, and I want you to pay attention, not just for anything, but for you to have a better understanding of the concepts of probability, and at the end of the day, you have good knowledge of the application of probability. And I believe that at the end of the day, it will be useful for you. Now, we are discussing this under the concept of statistical method in biological sciences. Introduction to probability. The concept of probability is relevant to experiments that have some uncertain outcome. And if you check some literatures, different author define probability as the measure of uncertainty. The measure of uncertainty. So, and as we all know that there are experiments that have some uncertain outcome, which we refer to as probability experiments. There are experiments that has certain outcome, which we refer to as deterministic experiment. Take for example in chemistry, I remember they taught us that when you mix hydrochloric acid and sodium hydroxide together, before you mix it, you know what the outcome will be. It will give you salt and water. So that is deterministic experiment. But an experiment that has uncertain outcome, like tossing of coin, coin has head and tail. So you don't know which of the faces will show up. Is it going to be head? Is it going to be tail? Then another experiment is rolling a die. Has 6 faces, 1, 2, 3 to 6, and you don't know which of the faces will show up. Is it going to be 1, 2, and so on? So all these are part of probability experiment that is has uncertain outcome. So these are the situation in which, despite every effort to maintain fixed condition, some variation in the result during repeated trial of experiment is unavoidable. As used here, the term experiment is not restricted to laboratory experiments, but include any activities that result in the collection of data pertaining to phenomena that exhibit variation. As I've mentioned, tossing a coin, rolling a die, and so on and so forth. If we talk about unborn child, also having a child by a couple, and it's an experiment that has uncertain outcome in terms of the gender of that child, can be male or female. Then planting a seed also is an experiment that has uncertain outcome. The seed may germinate or may not. So now, and so on and so forth. We have different experiments in that category, as I've explained earlier on. Now, let's look at the definition of some terms here. Though I've explained this, the first one there is random or probability experiment, which I've explained earlier on. This is an experiment whose outcome is determined by chance and differs at each time the experiment is conducted under the same condition. So the result is uncertain despite maintaining the same condition in performing the experiment. the outcome keep changing. So a random experiment satisfies the following condition. Number one, the experiment can be repeated under the same condition. Number two, the result is unknown in advance. Number three is that all possible outcome of the experiment can be predicted. So you can predict which one will show up, but you can only predict. You cannot be so sure that your prediction will occur. So, however, if the outcome of experiment is known in advance, then it is called deterministic experiment, as I've explained when we started. So now, what is outcome? We keep mentioning outcome. An outcome is the result of a single trial of a probability experiment. If you toss a coin once, whatever show up is an outcome. So then the next term to discuss or explain or define is sample space. So a sample space is the set of all possible outcomes of a probability experiment. So, and we have examples given here. The first one there, tossing a coin, as I've explained, head or tail. Those are the sample space, that is possible outcome that you may have. Then roll a die. We have 1, 2, 3 to 6. So those are possible outcome you may have. So a sample space is the set of all possible outcomes of a probability experiment. So we have some examples given there. Then sample point. Each item or unit in the sample space is called sample point. That is, I think, straightforward for us to understand. Now, we have here some exercises to help us understand the concept, which you may go through personally. The one of the exercises is that determine the following, that is the sample space for gender of 3 children in a family. So take for example a couple want to have 3 children. What are the possible outcome of gender combination of 3 children they may have? By the time you go through it, you have about 8 sample points, and they can have, for example, let me give you hint here, the first child to be a boy, the second child to be a boy, the third child to be a boy. So they may have boy, boy, boy. That is a sample point. Then they may have first child to be a boy, second child to be a boy, third child to be a girl. That will now be boy, boy, girl. That is another sample point. So by the time you do that combination like that, you have 8 sample point. Now, the second one is the sample space when 2 dice are rolled simultaneously. And the third one is the sum of the sample space in that second example, that is when 2 dice are rolled simultaneously. Now, the next thing I want to discuss here is like subheading is probability of an event. Probability of an event. So probability as a general concept can be defined as the chance of an event occurring. The chance of an event occurring. That is probability, the chance that an event occur. So many people are familiar with the probability from observing or playing games of chance, such as card games, slot machines, or lottery, and so many games like that of chance, Ludo, and so on and so forth. So in addition to being used in games of chance, probability theory is used in the field of insurance also. It's used in investments, is used in weather forecasting, and in various other areas. You may think about. In day-to-day activities, we encounter experiments or events that the outcome is random. The outcome is uncertain. We can only predict, we are not sure what the outcome will be. So probability of an event is the proportion of time an event occur. Proportion of time an event occur. Take for example, event A, for instance, is expected to occur when the experiment is repeated under identical condition, and is denoted as the probability of A is the number of time event A occur over the number of sample space, that is possible outcomes. So now so now for example, in the experiment of tossing a coin, the probability of obtaining a head is denoted as 1 over 2. That is, head is just one sample point. Out of how many possible sample points do we have? 2. So probability of having a head is 1 over 2. Then let's look at the axioms or properties of probability. Probability has some properties that you should know. That is, uh, take for example, if you are trying to obtain the probability of an event and you get a certain answer, you should know if your answer is correct or not. So the probability of an event, say event A, ranges between 0 and 1. So where the probability of an event equals to 0 means that that event is impossible, and the probability of an event equals to 1 means that that event is certain. So others ranges between 0 and 1, and the closer to 1 the probability of an event is, the more certain that event is, the more likely that event occur. So then the probability of the sample space is equals to 1. That is, if you sum all the probability in the sample space, in the region of the sample space, should give you 1. So, and that is about that. The properties of probability. It is possible to combine two or more events for a particular experiment. Therefore, the following relations can be obtained. So let's look at the relations in terms of probability of events. So if you have two or more events, uh, especially in the samples in a sample space, you can obtain the probability of the union of two events. So the union of events is the event that consists of all outcomes in all the events. The union of events is the event that consists of all the outcome of an event. Take for example, if we have events A1, A2 to AN, then the union of these events are written as A union. That symbol there means union. That is A union. That symbol there means union. That is A1 union, A2 union, and so on till AN. So it can be written also as A1 or A2 or and so on and so forth. So we also have intersection of events. This is the event that consists of all outcome common to all the events. Take for example, if we have two events, say event A and B, and we want to obtain the intersection of event A and B, we are referring to elements of event A and that are common to element B, that is elements that are common, outcomes that are common in the two events. So we also have, we will discuss these more details very soon. So we also have complement of events. So complement of events, given an event A, for example, the complement of event A denotes as A prime, uh, is the set of all outcome in the sample space that are not contained in event A. That is, all the elements in the sample space that are not in event A, that is A complement. So, and some literatures we put it as A with superscript C, but we are using A prime here. So if you check some literatures, you will see A with superscript C. Now, the next thing here is mutually exclusive events. So two events or more are said to be mutually exclusive if their interaction is a disjoint set. Well, that may be a little bit big for you to grab. Let me break it down. So, two or more events are said to be mutually exclusive if they cannot occur simultaneously together. So that is, two events, say event A and B, are said to be mutually exclusive if the intersection of A and B is an empty set. That is, they have nothing in common. So now let's look at the last one before we go into practical example. The last one is exhaustive events. Exhaustive events. So the event A1, A2 to AN are said to be exhaustive events if they cover all possible outcomes of experiment. So take for example in the experiment of rolling a die, whereby you have 6 possible outcomes, that is number 1, 2, 3 to 6 possible outcomes, and let event A be that we are talking about having even number, and event B is having odd number. You know that event A we have elements such as 2, 4 and 6. Those are even numbers there. Then event B will be having 1, 3 and 5. That's those are the odds number there. So now event A in that case and event B are exhaustive events. That is, if you put all the elements in event A and B together, if you obtain the union of A and B, then you have 1, 2, 3, 4, 5, 6, which is contained in the whole sample space, meaning that all the elements in the sample space are exhausted by A union B. So now let's look at some examples here. I will go through some of the examples together with you, while I will allow you to study the rest by yourself. Let's look at the first one. Now 20 discs are marked with the numbers 1 to 20 inclusive. They are placed in a box and one disc is drawn from it. What is the probability that the number of the disk will be a multiple of 5? Now, so let's look at this as the solution now. That start by stating what is given in the question. In the question, we are given sample space S to be 20. That is, 20 elements are there, 20 outcomes are there. Then let E be events of multiple of 5, having a number of multiple of 5, whereby you have 5, you have 10, you have 15, you have 20, and now we want to obtain the probability of that E, that is event of multiple of 5. Now the elements we have in the E event are 4, that is 5, 10, 15 and 20, 4 elements. So now the probability of E now will be the number in event E over the total number in the sample space, which is 4 over 20, and simplify that. That is 4 in 4 will be 1, 4 in 20 will be 5. So that's about that. Now the second question says that a bag contains 5 blue balls, 3 red balls and 2 black balls. A ball is drawn at random from the bag. Then obtain the probability of A, probability of red balls; B, probability of black balls; C, probability of not a black ball. Now, if you look at this, the sample space for this experiment is they say a bag contains 5 blue balls, we have 5, then 3 red balls, we have 3, then 2 black balls, we have 2. So 5 plus 3 plus 2 makes 10. So we have 10 total outcomes. Now, the red balls are 3. So the probability of red ball will be number of red ball over the total number of balls. That is 3 over 10. Then the probability of black ball is the number of black ball, which is 2 over the total number, and that is what gives us 2 over 10. Then the probability that not a black ball, there are 2 ways we can solve that. If it is not a black ball, then it will be blue ball or red ball. If it is not black, then it will be blue ball or red ball. And how many blue ball do we have? 5. And how many red ball do we have? 3. Add it together, you have 5 plus 3 making 8. That's what gives you the 8 over 10. Now, another way to solve this is by saying that if it is not a black ball, then it will be, since we know that the sum of all the elements in the sample space, the probability of all the outcome in the sample space will be 1. Now, if we subtract the probability of black ball from 1, then it will give us the probability of other balls in the sample space that are not black. So that's what gives us this idea of 1 minus probability of black ball. That is, probability of black ball is 2 over 10. So 1 minus 2 over 10 will give you 8 over 10, which is the same thing we obtain by using the other methods. So now, the third one here, a die is rolled, calculate the probability, blah blah blah. Let me leave that one for you, and the exercise here for your personal exercise. So just go through the exercise and let me know. If you have any question, of course you can put it down in the comment section, then we attend to you later. Now, the next I want to talk about here is the law of probability. The law of probability. Now, the first one is the addition law of probability. So for any 2 events A and B, the probability that either A or B or both will occur are denoted by probability of A or B, and is defined as the probability of A or B is equals to probability of A plus probability of B minus probability of A and B. Now, take note, this is not always the case. There is a condition attached to this. Now, so meaning that probability of A or B can be written also as probability of A union B, and of course that will be probability of A plus probability of B minus probability of A intersection B. Now, remember, we said that probability of A intersection B means probability of A and B having common elements. Now, what if A and B do not have common elements? It means the probability of this A intersection B will be 0. So which means in a situation whereby A and B have no common element, that is A and B are mutually exclusive events, then probability of A union B will be probability of A plus probability of B. So it means that this one only holds when event A and B have common elements, that is they are not mutually exclusive events. So but if A and B are mutually exclusive events, then this probability of A intersection B will be 0. So let's look at it using a Venn diagram. So now in this case, now this A and B has no common element, that is, they are mutually exclusive events, so they have nothing in common. So, and probability of A union B will be probability of A plus probability of B. So probability of A intersection B will be 0, so minus probability of A intersection B will be out of that. Now in this case we have A and B are non-mutually exclusive event, that is, they have common elements. So probability of A and B, or probability of A intersection B, exists here. So they have a common element which will be in this region. So in that case, probability of A union B will be probability of A plus probability of B minus probability of A intersection B. So take note of that. I've explained this. So let's look at an example there. So if 30% of Nigerians are obese, that is event A. Let's call that event A. 30% of Nigerians, for example, let's say they are obese, and that 4% of Nigerians suffer from diabetes. So let that be event B. Then 2% are both obese and suffer from diabetes. So that is 2% have the event A and event B. Now, what is the probability that a randomly selected person is obese or suffer from diabetes? So in that case, you say that probability of event A is 30%, which is 0.3. Probability of event B is 4%, which is 0.04. And probability of both A and B, that is having both experience of obese and diabetes, is 2%, which is 0.02. In this case, probability of A and B exists, that is, event A and B are mutually exclusive events. So in that case, probability of A union B, or probability of A or B, probability of A plus B will be probability of A plus probability of B minus probability of A and B, or probability of A intersection B. So in that case, you now have 0.3 plus 0.04 plus minus 0.02, and that will give you 0.32. So I hope you understand that, please. If you don't, please let me know in the comment section. Now, the next example here says that the Corporate Research and Development Center for 3 local companies have the following numbers of employees. So we have the first is 110. The second is 750, and the third is 250. If a research employee is selected at random, find the probability that the employee is employed by US Steel or Alcoa company. So in this case, we have 3 companies, and we want to obtain the probability of US Steel or Alcoa. Pardon me if I don't call that correctly. So, and that will be probability of US Steel plus probability of Alcoa, meaning that there are no employee working for both company. In that case, we just find the probability of employee in the first plus employee in the second company and add them together, and that will give you 86 over 111, as we have it here. So I hope you understand that. So we've considered examples on mutually exclusive events and more non-mutually exclusive event. I also have two exercises here for your practice, so try to do them and let me know challenges you may be having there. So the next law of probability we are discussing is multiplication law of probability. So when two events are independent, that is, the occurrence of one event does not affect the chance of occurrence of the second event, then the probability of both events occurring is, say, event A and B now will be probability of A and B. So, and that will be probability of A multiplied by probability of B. So that is, A and B means probability of A intersection B will be equals to probability of A times probability of B. Remember, if both events are independent, if they are independent. But if the two events are dependent, that is, the occurrence of one event uh, uh, does affect the chance of occurrence of the second event. How do we obtain the probability of A and B? So that would be probability of A and B, or probability of A intersection B, equals to probability of A multiplied by probability of B, given that A had occurred. It means that A must occur before event B can occur. In that case, the probability of the product of A and B will be the probability of A multiplied by the probability of B, given that A had occurred. So take note of that. So, and this aspect is what we refer to as conditional probability. Conditional probability. So now let's see an example on that. Example, the first one here says that a coin is flipped and a die is rolled. Find the probability of getting a head on the coin and 4 on the die. So in that case, we know that coin and die has nothing in common. So the uh, occurrence of obtaining 4 from a die is not affected by uh, occurrence of or obtaining head from a coin. So probability of head and 4 will be probability of head multiplied by probability of 4. Probability of head will be 1 over 2, while probability of 4 will be 1 over 6. As I've explained earlier on, 4 is just a number out of 6 possible numbers, and head is just an outcome out of 2 possible outcomes. So, and by the time you simplify that, you have 1 over 12 as the answer. So then the second uh, example here is on Wide World Insurance Company. Find that 53% of the residents of a city have had home owners insurance, called that H, with the company. And of these claims, 27% also have automobile insurance, called that A, event, with the company. So if a resident is selected at random, find the probability that the resident has both home owners and automobile insurance with the company. So in this case now, we have given the probability of H is 53%. Then the probability of con event, which is A, is 27%. Is 27%. Now we want to obtain the probability of H and A. So now uh, in this case now, um, we with this statement of these claims, that is of the claims that have event H, that is that have home owners insurance. So meaning that the occurrence of this uh, is conditioned on H. So which means A depends on age, is conditioned on age. So that now will be probability of age multiplied by probability of A, given that age had occurred. So, and that will give you 0.143. Wow. I hope you understand that. If you don't, please let me know in the comment section or in the discussion group or on both platforms. So at least I will respond to your questions, and that will give you a better understanding. So the next one is conditional probability. Well, I've explained this partly earlier on. So the conditional probability of an event B occur after event A has already occurred. That is probability of B given A, and that can be obtained by saying probability of A and B divided by probability of A. So, and that is implied probability of A intersection B over probability of A. Don't forget, earlier on we've expressed it as probability of A and B is equals to probability of A multiplied by probability of B given A. It only makes sense if you simply obtain the subject of the formula for probability of B given A, and it will give you this. It's as simple as that. Um, I think we learned that in secondary school. Okay, so let's look at this example now. A box contains black chips and white chips. A person selects two chips without replacement. If the probability of selecting a black chip and a white chip is 15 over 36, and the probability of selecting a black chip on the first draw is 3 over 8, find the probability of selecting the white chip on the second draw, given that the first chip selected was a black chip. So now you can read that question second time to have a better understanding if you are confused actually. So now to solve this, it only makes sense to really lay like the foundation, start from the beginning and jot the information you can get from this question. Take for example, a box contains black chip and a white chip. So from here we can say that, okay, let event of selecting black chip be B. Why? Letter B for black. Let W be the event of selecting white chip. Why? W for white. Make sense now. So a person selected two chip without replacement. Take note of that. Selected two chips. After picking the first one, he did not return it into the container before picking the second one. So meaning that as at the time he is picking the second one, the total number of chips is -1. So take note of that. Now, if the probability of selecting the black chip and white chip is 15 over 56, probability of the two, selecting both black and white, that is probability of B and W is 15 over 56, and the probability of selecting a black chip on the first draw is 3 over 8. Probability of B, that is black now, is 3 over 8. Now find the probability of selecting white chip on the second draw, given that the first chip selected was black chip. So we are talking about probability of W given B here. So, and that will be probability of B and W over probability of B. So easily 15 over 56 divided by 8 over 3. And by the time you simplify that, you have 15 over 53 divided by 3 over 8, and that will give you this here. And by the time you simplify further, you have 5 over 7 as the probability of conditional probability of white given black. So this second example, I will leave it for you to practice yourself. Then we have exercise also for you. Then the next is marginal probability. Marginal probability. So the marginal probability of a subset of a collection of random variable is the probability distribution of the variables containing in the subset. It gives the probability of various values of the variables in the subset without reference to the values of other variables. Now, given the table below, for example, we have the distribution of probabilities on the one side, that's row. We have gender, boys, girls. On the column, we have that is the presence of RH plus, that is yes or no. So yes means there is RH plus, no means there is RH negative. So, and this is the probability of boys having RH plus, and this is the probability that 0.0763 75 0.0765 is the probability of boys having RH negative, and so on and so forth. So in a certain city hospital, 85% of newly born babies are RH plus. That is, they all have the RH plus antigen on the surface of their red blood cell. Otherwise, it is RH negative. So it is also known that about 51% of all babies born at these particular hospitals are boys. And suppose an individual newly born baby is randomly selected from this hospital, then obtain the probability 1 that selected individual is a boy. It's given already. 51%. The probability of having a boy is 0.51. Probability of a girl, of course, is 1 minus that, which will give you 0.49. Then the probability of RH plus positive is 85. Of course, that of negative will just be 1 minus that, which is 0.15. Then we can as well obtain the probability that a child is a boy and is RH positive. The probability that a child is a boy and is RH positive is what we have here, which is 0.4335. 0.4335 from the table. So, and that is about that. So we can easily from here obtain the marginal probability from the table, which we have just done there. Now we have a question here also. Consider the following data which relate to a group of 1,000 randomly selected adults who were asked if they are in favor of abortion or are against it. So we have 451 male and 549 female. In total, they are 1,000. And those who are in favor are 558, both male and female. And those who are against are 442, both male and female. And you will see from the table that 248 male are in favor and 310 female are in favor of abortion. Now, the question is, we can from here obtain the probability of male, which is 451 over 1,000, female 549 over 1 out of 1,000.
Then those who are in favor are 558 out of 1,000, and those who are against are 442 out of 1,000. So the above are four marginal probabilities or simple probabilities. Notice that this probability involves single events. A single event. Single event means just male, just female, in favor, not in favor. If we want to go further, we can obtain probability of male and in favor. That will be 248 over 1,000. So that's about that marginal distribution. So I hope you understand that. Okay, till later. Bye for now.